Hello and welcome back to App for You. In this particular video, we'll be discussing an important problem from arrays, and basically we'll be implementing search. And you might think that this problem is very simple, right? Because we just have to find number of occurrences. But no, we'll be trying to find out more efficient approaches of finding the number of occurrences of an element in a sorted array. Now this problem is very simple, very short, but yes, it's like it's capable of ruining your interview if you are not aware of this approach of finding the occurrence of an element more efficiently, right? So it's something like chota bomb bada dhamaka. So anyway, I feel that. So let us see how we can basically deal with this particular problem. So basically the problem says that we are provided with a given sorted array, right? So we basically have a sorted array, a arr, okay, and the size of the array is n, and we are provided with an integer x, and we basically have to find out what is the count of x in this particular array, or in the sense you can say what is the number of occurrences of this particular variable x or number x in the array. So an important thing that they have basically provided to us is basically that the information says that it is sorted array. So yeah, they have made our work quite easy. So basically they have provided us with a sorted array, and we need to count the number of occurrences of x in that array. The naive approach is very simple, right? We just will be doing a linear search and look for the number of x in the array. The time complexity will be order of n, but in the interview obviously the interviewer will not expect this particular response from us, right? Anyway, we shall see the naive approach also. So what is the naive approach? So naive approach will basically do what? Basically we have received an integer array and the length of the array and the variable x, which is number x, which is to be searched. So the naive approach will say declare a variable I, and then just start traversing from I equal to 0, I less than n, I plus plus. I'll be very quick. And you also declare a variable count that will basically keep the count of the number of occurrences of x, right? So now you are traversing from left to right, and you see that if array of I is basically equal to x, which indicates that if you find any element which is equal to x, just say count plus plus. Done. Once you have completed the traversal from left to right, okay, once we have basically completed the traversal from left to right, means suppose this is the example. Suppose we have let me write here, suppose I have an array where I have elements like 1 1 2 2 2 2 3. Now what I'm doing, I'm starting from here and I'll end here, and in the process what I'm doing, I'm just comparing what is the value of x that is received here is suppose 2. So I want to find the number of occurrence of 2. So I'll come here, I'll say is this equal to 2? No. Move next. Is this equal to 2? No. Move next. Is this equal to 2? Yes. Count equal to 1. Move next. Is this equal to 2? Yes. Count equal to 2. Move next. Is this equal to 2? Yes. Count equal to 3. Move next. Is this equal to 2? Yes. Count equal to 4. Move next. Is this equal to 2? No. Move next. End the loop. So basically the count is equal to 4 and 4 will be returned here, right? So return 4. A very naive approach. What is the time complexity? So basically time complexity is linear, order of n. So if you just compile this particular code, it will work fine. So the time complexity of this approach is basically order of n, right? You can see the occurrences of 2 is 4, and I think that this will be submitted because this problem here have been designed such that it will accept order and time complexity. But we shall try to make it more efficient. Okay, you can see the problem is accepted, but yes, this is not our goal. Our goal is to make it more efficient. So since the array is sorted, can it be made more efficient? Obviously yes. Now if you can exploit the use of this particular word sorted, since the array is sorted, and we know that for finding an element in the sorted array, binary search is the most efficient algorithm that can be used, because binary search basically takes log n time, right? So can we use binary search for this particular purpose? Let us see. So let me just increase the size of the screen, right, to make things more clear. So I'll just copy this example. Okay, now let us make things more clear. Okay, so can we use a binary search? So let me first of all erase whatever I have done here. So I hope you are aware of how binary search actually works in the sorted array. So if I write the example, so I'll basically be having 1 1 2 2 2 2 and 3. So what will binary search actually do? Since the array is sorted, so binary search will basically take the very first index, the last index, find the middle element, and check if the middle element is equal to the element or not, right? That is what we do in the binary search. So if I do the binary search, basically I'll be using a variable f is equal to 0 pointing to the first index, right? So let me write this. Let me write this here as first index, right? and I'll be using one more variable, integer L is equal to n minus 1, which is nothing but my last index, right? Last index. What next? Now I can say that while f is less than equal to L, what should I do? I should basically find the mid. So mid is equal to f plus L by 2, right? And you should also declare a mid here, integer mid. Done. Now once you found out the middle element, you should first of all compare whether the middle element is equal to x or not. So if array of mid equal to x, what does it indicate? It indicates that yes, the element is found, so we will return mid. Now this is a general binary search that we do, right? Otherwise, else if we find that array of mid is basically greater than x, the element that we want to find. So if array of mid is greater than x, which means that the element in between is larger than the value that you are expecting, and since the array is sorted, it indicates that obviously the value will be towards left. So since the value will be towards left, so basically you should update your L pointer, right? L pointer, because L is basically pointing to the left. L is basically pointing to the right window, and F is pointing to the first index, right? This is the size of the array. If you found an element here in between, suppose the element is 9 and you are looking for an element 5, then where will the 5 be present? 5 will be present in this subarray. So if 5 is present in this subarray, you should reduce the size of this window. So I should basically bring this pointer to this position. And which pointer is this? This pointer is L, and this is my F pointer. That is why if array of mid, now if array of mid is greater than the value that I am searching, in this case, what should we do? We should basically update the pointer. Which pointer? L pointer. L is last pointer will come to mid minus 1. Done. Else if array of mid, now if array of mid, sometimes it might happen that it is less than the value x you are searching. So basically it might also be the case sometime that this value here is suppose 4 and you are looking for 5. Obviously 5 will not be present in this subarray, 5 will be present in this subarray. So you should basically this particular pointer to this point, which is mid plus 1, right? So I'll update the pointer F to mid plus 1, right? And this will continue. And when will it stop? It will stop the moment I find the element a of mid is equal to x, right? The moment I find array of mid is equal to x, it will return the index of that particular position. But keep in mind one thing. Let us do the working, whether this will work fine or not. Now see, as per the binary search problem, now this is the binary search, this is the code for binary search we have written, right? The general binary search, not normal binary search. Now here L is equal to 0 and N is equal to what? 3, 4, 5, 6, 7, 7. N is equal to 7. So basically F will be equal to 0 and L will be equal to N minus 1, which will be 6, right? So this index is basically 6, this index is 0. So first time mid will be F plus L by 2. So 0 plus 6 by 2 is 3. So it will basically point to index number 3. What is the index number 3? The index number 3 here is basically this index, right? This element. And the moment we find that array of mid is equal to x, we are just returning mid. What we are doing? We are returning this mid position. And what is the value? 3. Index 3. Is this the answer? Obviously this is not the answer, right? Because this is just returning the index of this element, right? Now we know that the elements might be duplicate, that is an element may be present more than once. Then why am I just depending on this particular value? Here I just pointed to this, and this is basically be useful to see if an element is present in an array or not. But I don't want to basically check whether an element is present or not. I want to count its frequency. So for that, what we have to do, you see there are more 2's toward the right of it and there can be more 2's toward the left of it. Getting the point? Now this binary search, what is it doing? It is basically helping me to detect if an element is present or not. Obviously I found out they are saying return mid when a of mid is equal to x. So basically it is returning the index in which 2 is present, which means I am getting an idea that 2 is present in the array. But I am not concerned about the presence, I am concerned about the frequency. So for that, since 2 is present here and I know that the array is sorted, so it might be the case that some more 2's are towards left of it and some more 2's are available towards right of it. So what can I do? Once you get this particular position, you can just run a loop, okay, from this index towards left as long as you are getting 2 and keep the count. And another time again you can run a loop from this index towards right as long as you are getting the 2, maintain the count. And finally you will add both the counts to get the frequency, total frequency of 2's. Getting the point? I hope you got the point. How will this particular problem work? If you modify this binary search, what we can do, once we are getting the element x, instead of returning mid, what we will do, we will note down the index position of mid, and we will basically run a loop from that position towards left, as long as we are getting to keep the count, and from that mid position towards the right, as long as you are getting the 2, keep the count, right? And we'll basically add both the counts. So what will happen in that particular case? The time complexity will be time complexity will basically be order of log n. Why? For finding the element 2 plus, in the worst case, what might happen? In the worst case, suppose your array consists of 2, 2, 2, 2, 2. So in the worst case, if your array consists of 2s only, all the elements are 2. So once you found the middle 2, what will you do? You will start from middle position towards left, and you will keep the count of all the 2s towards the left of this, all the 2s towards the right of this. So in total, you have basically traversing the entire array. So that will be order of n. So you see, order log n is very, very small than order of n. So overall dominant time complexity will be order of n only. Do you think it improved? Definitely not. Which means a normal binary search will also not help us to solve this particular problem efficiently, right? Even if I am finding the element and then I'm running a loop from towards left subarray or towards right subarray, then also it will not perform well, right? So what is the solution? We shall come up with the solution. Okay, so now let us basically try to code this particular problem where we discussed right now, right? This particular problem wherein after finding middle, we will go to left subarray and then again we will count the elements in right side in the right subarray. So how we should do? Alright, so let us now see how we will basically implement this particular problem, right? So now I will be writing the code for the approach that we discussed right now, in which basically we will modify the binary search slightly, in the sense that suppose I have 1 1 2 and 3. Once I am getting the middle element, then I will traverse towards left and maintain the count, and traverse towards right and maintain the count, and then finally I'll return the total number of occurrences of that particular element, right? So this will be done by just slightly modifying the binary search. So how will we do so? Basically, this is my binary search. You can see the moment f is less than equal to L, since as long as f is less than equal to L, I'll come inside and I'll basically say that mid equal to f plus L by 2. I'll be basically finding the middle index, and then I'll compare if the array of middle index is equal to x or not. Now the moment I'm finding that the middle index is equal to the element x, we were returning mid. Otherwise, if the element in the middle position is greater than the x, what does it mean? As we discussed, if the element in the middle position, suppose is 9 and I'm expecting 5, so if this element in the middle is greater than the element I want to find, which indicates that the element that I want to find is basically present in left subarray. So for that purpose, I will be modifying my L pointer to mid minus 1. Similarly, if the element in between is smaller than the element I want to find, suppose I want to find 15, so basically this element in between is smaller, which means 15 will be present towards right of it, right subarray. So for that, I'll be modifying the f pointer to mid plus 1. Done. So this way basically the binary search was working, and as soon as I found out the first occurrence, of 2, suppose here, it was just returning mid. But right now we'll modify this. Why? Because I don't want it to return anything right now. Instead, what you should do is basically I'll be declaring 2 more pointers, integer I, comma j, and I'll declare one more variable count to keep the count. Okay, so count initially is equal to 0. What should be done now? The moment you find that the middle element is matching with the element that you want to find, I will just traverse till left. So I'll say while. So first of all, initialize j is equal to mid minus 1. Okay. So basically, I'll be pointing toward the element just before it. Suppose example here, I have the elements 1 1 2 2 2 2 3. Right. This is the array. So this is the array I have, and this is the index 0 1 2 3 4 5 6. So what is index 0 plus 6 by 2 is equal to 3. So mid is equal to 3. So the moment mid equal to 3, you got 2 here, and this is matching with the value x equal to 2, right? So which means from now onwards, this is the mid where mid is pointing. J should point to just before it. So J should point here. Okay. And what will we do? We will say that we'll run a while loop, and which will say basically while j is greater than equal to 0, that is move left while j greater than 0, and array of j basically should match with the element array of mid, or simply you can say array of j is equal to x, anything. Okay, array of j should match with equal to array of mid, and j should be greater than equal to 0. As long as this happens, you should just say count plus plus, and meanwhile after this you just decrease the value of j because I want to move left, right? So what will happen? j is equal to this position. So is this matching with equal to array of mid? Yes, true. And j is also greater than equal to 0, count plus plus. So count will become 1. Move j minus minus. I move j minus minus, j will now point to this value. And this value, obviously j is greater than 0. Fine. The index is greater than 0. But this value is no longer equal to array of mid because it is 1 here. So basically I'll come out of this loop. Okay. So far count is equal to 1, which means only 1, 2 is present towards the left of the middle 2. Now what will happen? Now I should declare my pointer I is equal to mid. Okay, so I will be basically pointing to mid, and from here I will be moving right to count the occurrences of 2. So now I'll say same thing. I'll just copy this particular loop because we are doing the same thing. Control C, Control V, and this will say that while I is less than n, because I is moving towards right, so I should be basically less than n, and array of I should now be equal to array of j, because I am just wanting to find whether any 2's are present in the right or not, right? Or you can write here array of I is equal to x, anything is possible. And now you should just increase I plus plus, and finally what we should return? We should return the count. Done. So this particular problem will also work fine. Let me just compile it. So this particular approach will also work fine, and it will give you the answer. So I hope, okay, one more thing, I should give a break here, okay? Why? The moment though both while loops have done their execution, you should basically stop, right? The moment you have completed traversing left part and right sub array, you should basically stop. Otherwise it will lead to time limit exceed, okay? So I should give a break here because this is traversing the left sub array, traversing the right sub array from the middle position. Basically both will maintain the count in the variable this, and count will be returned here. You can see there are 4 occurrences of 2. So this particular logic also works fine, and it also gives you an answer correctly, right? So we discussed 2 approaches, and both of them yields the result. What is the time complexity of this approach? As I said you, the time complexity will be, first of all, order of n. Time complexity will be order of log n for finding the middle element, plus in the worst case you may move till the left extreme, you may move to the right extreme if all the elements in the array are same. If there are all 2's, what will happen? From middle 2 you will be moving to the extreme 2, and again from middle 2 you will be moving to extreme right 2. So overall you are traversing order n. So the dominant factor is order of n, so overall time complexity will be order of n. Obviously this is also not a good approach to solve this particular problem. Any efficient approach. Right now we will start with the most efficient approach to solve this particular problem. So this time we'll be discussing the most efficient approach to solve this particular problem. What is the most efficient approach? The most efficient approach says that, let me first of all clear whatever I have written. So okay, not this, let me just modify this. Okay, so we still have the binary search problem, right? Here what we were doing is, if we found that array of mid is equal to x, we should basically do return mid position, right? We should do return mid position in the normal binary search, but now we will not do that. Why? See, what we will be doing is basically, we have the array 1 1 2 2 2 2 3, right? We have this array. Now let me write this separately in a function binary search, the same code, okay? Same code, nothing to worry, everything is quite simple. I'm just copying it and going to paste it, okay? So let me rub this also. So I'm just creating a separate function binary search. Now just see how things are working. So integer binary search, what are the parameters it will be receiving? So the parameters that it will be receiving will be integer array, fine, comma integer n, comma integer x, and one more variable, integer flag. I'll explain why I'm using flag. Now I will just copying and pasting the entire function. So basically this is nothing but the same binary search function I have written separately. Why I have written separately, I'll say you. So see, we have just copied and pasted this binary search function separately. You can see this is entirely the binary search function. Now what should we do? Basically I should here right now find focus on, now you see, the moment you are getting to, now this is the index 0 1 2 3 4 5 6, the moment mid is equal to 0 plus 6 by 2, which is equal to 3, the moment you are finding an element in middle position, what I can do is I can find the first occurrence of 2, that is what is the index of the first occurrence of 2. So for I know that definitely will be present in the, possibility is that it will be present in the left sub array. So rather than moving towards right now I will be calling the binary search on this left sub array. Keep on calling the binary search on this left sub array until you get a 2. right, until you are getting 2. So by this I will be getting this index of this position, that will be 2, and keep on call, and then again next time I will be keeping on calling the binary search on the right subarray only. 2 separate binary search you will be calling on the left subarray and the right subarray, and this will keep on calling as long as you are getting 2. So basically this will give me the last occurrence of 2. Last occurrence of 2 is basically nothing but 5. Getting the point? So what will be the number of occurrences of 2 basically? So this 5 minus 2 plus 1. So this is 5 minus 2 is 3 plus 1 equal to 4 will give you the value of the last occurrences. So value of the number of occurrences of 2. So for that what I am doing is basically I will be declaring a variable here, integer first occurrence. So integer first occurrence will give you the index of the first occurrence. Integer LO will give me the index of the last occurrence, right? Now I will declare first occurrence is equal to, sorry, F0, FO. First occurrence is equal to, you have to call the binary search, and basically what you will be doing is you are calling a binary search, and I am passing the array ARR. The size of the array is n. The value that I want to search is x, and I will be passing the flag equal to 1 because I want to find the first occurrence. I'll show you how it will work. Last occurrence, you'll just call the binary search function, binary search array. You will call n x and you will pass 0. Why? This will basically help you to detect that okay, you want to find the last occurrence. Now let us modify this code. What is happening is the moment I am finding the middle element, I am returning mid, isn't it? But now we should not return mid. Okay, now we should not basically return mid. So I hope this pointer is pointing fine. Okay, yeah, good. So we should not return mid now. Instead, what should we do? We should basically store this in some value index. Index is equal to mid. The moment you found out the mid, you just store the value of this mid, and now we should basically say that move the, now we will check if flag. What will happen? This is basically helping you detect, helps to detect whether we want first occurrence or second occurrence, right? So this will basically help us to detect whether we want the first occurrence or the second occurrence. So right now, if F0 is being called, if F0 is equal to binary search, if this part is called, then obviously it will pass 1. So flag will be 1. It means that it is interested in finding the first occurrences. And the first occurrences will definitely be present in which side? The first occurrences is basically present on the left side, left subarray. Once you found out middle position, the first occurrence of 2 if you want to find, you should basically look into the left subarray. And for looking into the left subarray, you should basically modify the pointer L, because L is pointing to the end. So basically you should bring this pointer to mid minus 1, right? So I will say here. So what should I say here? I should basically say L is equal to mid minus 1. Done. Else I should modify the F pointer to mid plus 1 because I want to look into the right subarray. If flag is 0, if flag is equal to 0, it indicates what? I want to find the last occurrences. You see, because last occurrences is when you are trying to find the last occurrences, you are basically passing flag equal to 0. What indicates you are finding the last occurrence. The last occurrence will basically be present in the right subarray, right of the middle part. So you have to basically modify the F pointer to mid plus 1. F pointer to mid plus 1. This will continue, keep on continuing, right? And what will happen? You will finally at the end return the value of index. So I'll basically say return index at the end. Return index. Got the point? So the index will be basically returned here. And now basically this will basically be return what? The last occurrence minus first occurrence, right? So let us see how it is working. Alright, so basically let us go through the code again. So the first index, last index, mid position, ij2 variables. Index I am initializing initially to -1, okay, and I'll be keeping a track of the variable count. Basically it is not required now. Count we are not keeping track, so basically we'll not be using the count variable. This is the code for the binary search, finding the middle element. If array of mid equal to x, means if element is found, the index will be updated to mid, right? and then we will just keep track of the flag. Now flag will basically help us indicate whether we want to find the first occurrence or the second occurrence. In case if flag is equal to 1, it means that we want to find the first occurrence, and the first occurrence will always be present on the left subarray. So basically L is equal to mid minus 1. That is why we should modify the L part. Else if flag is equal to 0, it means we want to find the second occurrence. So basically in that case the element will be present in the right subarray, and that means we have to modify the F part. So F will be equal to mid plus 1. Got it? Otherwise, if element is not found in the middle position, then we just modify accordingly. You know how to do this. If element is greater than x, then L equal to mid minus 1. If middle element is less than x, which means that the element x is present on the right side, so basically F is equal to mid plus 1. This is the normal thing that we do in binary search, right? And finally this will help me in the returning the index in the sense it will return the either the first occurrences or the last occurrences of x, in case depending upon the variable flag. Right, if you're passing flag equal to 1, basically this will return the first occurrence of x. If you pass flag equal to 0, it will basically return the last occurrence of x. That particular value index now, basically now you see F0 will be stored here, L0 will be stored here. Now when I'm calling F0, basically I'm focusing on the first index, right, first occurrence, because flag equal to 1 will focus on first occurrence by calling on the left subarray. You can see if flag is true, then L equal to mid minus 1 means I'm focusing on the left subarray. If I'm passing 0, then if flag will become false, and it will go to this part, and it will say look into the right subarray. So basically this will focus on finding the last occurrence of x. And finally I should check that if index is equal to minus 1, okay, or you say if index is not equal to minus 1, right, because we know that if element is not found, then index will basically be equal to minus 1 only, right, because element index will become mid only if the element is found. If element is not found, then index will remain minus 1 only. So if index remains minus 1, is not equal to minus 1, then we should basically return what? You know it well. We should say the last occurrence minus first occurrence plus 1, right? So return the last occurrence minus first occurrence index plus 1. This is the index, right? Suppose in this particular case, what would happen? The last occurrence is at 5, first occurrence is at 2 plus 1. 5 minus 2 is 3 plus 1 equal to 4. This is the total number of times the 2 is present. Otherwise, if index is found to be 1, what should we do? If index is found to be 1, we should basically return 0. As per the question, they have said to return 0. That's why we are returning 0, right? So I hope you got the intuition how this problem is working. Talking about the time complexity, obviously the time complexity is order of log n only. You see, because first log n for this particular part, right? This particular part is taking log n times, right? Again, once I'm finding the middle element, that is once I'm detecting that yes, element is present in between, again I will be taking log n time to find the first occurrence, and I will be taking log n time to find the second occurrence also, right? Because you see, this is what? This is nothing but reducing the size of the array to half, isn't it? This also is reducing the size to half because it is focusing on right subarray, and this is focusing on left subarray. So this will not be conducted parallelly. It will depend upon the call. If I am calling this, 1 indicates flag equal to 1, means yeah, I am focusing on the first occurrence. So just complete finding the first occurrence. Once I am done with that, next time this function will be called, that will focus on finding the second occurrence. Once I am completed finding the second occurrence, so first occurrence will give this position, second occurrence will give you last occurrence will give you this position. Subtract and add 1 will give you the total number of frequencies of that particular element x, right? So I hope the video was intuitive and you got the intuition how to solve this particular problem. I have discussed all the approaches from the naive approach to the most efficient approach, and yes, I hope the video was worth watching. And the time complexity, as I said, yes, order of log n. Talking about the space complexity, we are not using recursion, nothing else. That is why space complexity is constant only, right? So let us now run this particular code, and if I run this particular code, things will work fine. And let us see. Okay, so where is the mistake? Okay, so not index, basically FO, because I have not declared index variable, right? So basically FO, suppose FO only. The first time I'm finding the first occurrences. So in the first time only, if I'm returning, if I'm getting minus 1, it indicates I have no element present, right? So it should be FO. So let us see. Yeah, the output is 4. You see 4 occurrences of 2. Submit the code. Yeah, the code works fine. So that's all from this particular video. I hope this video was helpful. In case of any doubt, please feel free to put it down in the comment section, and just like, share and subscribe. Thank you.